Hi all. So today we will discuss about the road estimation, and I think you're already aware that we had already covered other building structures, civil engineering structures like normal buildings, residential buildings, bar bending schedule, or bar septic tank, and some other structures like beams, columns, retaining walls, etc. We had already covered, and today we will go to a new topic, that's road estimation. This will be very crucial once you start working, and you will have to find to what are the quantities required for road construction. So what should be the filling quantity, what should be the cutting quantity, like that. There will be some terms that you will have to deal with under this topic. So anyway, we will study all those topics in detail now. So road estimation. So from this picture, you'll be, I hope you'll be understanding what is this picture all about. This is basically a cross section. One second. So this is basically a cross section of a road. Okay, this will be in a trapezoidal shape, and one second. So the road will be like this. If we are considering the uh, three-dimensional view, the road will be like this, and this will be the place above this surface only that vehicles will be traveling. Okay, so this is the cross section. Sometimes the normal ground will be at a lower level, and we'll have to add some more soil so that the level of road will raise to the desirable level. So in that situation, sometimes we'll have to fill more quantity of soil to the level ground to attain the desirable road height. And sometimes we'll have to, if there are some elevated ground on the way of road construction, we will have to cut that excess soil on that way, and that is what we call cutting. Okay, so that is I hope we now you understand what is the difference between cutting and filling. Okay, filling is also called banking. It's already shown here. Okay, so in this picture you can see that the depth of filling will be small d, and suppose if the slope is s is to 1, the horizontal distance, this distance will be st, where d is the height, b is the top width of the section. So the total bottom width will be b plus sd plus sd, right? So this is also b, this is also b. Okay, this is b, this is sd, and this is sd. So the terms are already mentioned here. B is equal to formation width, D is equal to height of filling or cutting, S is to 1 is the side slope. Okay. Basically, under this topic, we will be calculating what is the quantity of filling, or what will be the quantity of cutting. So all those things we will have to find under this topic. So the area, what will be the area of this trapezoidal shape, trapezium shape? Area of the rectangle plus twice the area of the triangles, right? There are two triangles here, and there is one rectangle at the center. So we will have to add the area of this rectangle and the two triangles. That is what we that is what is mentioned here. The area of the rectangle plus area of the triangle. So the area of the rectangle will be b into d. As you are already aware, B is the breadth and D is the depth. Is shown here. So BD plus half area of the triangle will be, area of the triangle is half base into altitude. So half into base will be SD, and height will be D. So half into, actually there are two triangles, so it will be 2 into half into base. This is the base and this is the altitude. So uh, this is the area of the two triangles, and this is the area of the rectangle. So combining together, we'll get that area of the trapezium will be BD plus SD square. This is a very important uh, formula. You will need this formula for calculating the quantities. Okay, so going on, uh, for finding if we are given a uniform level, I mean uniform section, we can have different formulas to find the quantities of road work. There are three formulas. One is mid-sectional formula, the second is mean sectional formula, and third is prismoidal formula. The mid-section formula, as per the mid-section formula, we have AM is equal to BDM plus SDM square. A is the area. Okay. Uh, so DM, what is DM? DM is the average of D1 and D2. This is D1, okay, and D2 will be at the back. There will be a similar section here, okay. So there will be a similar section here. So this will be the height of D2. Okay, it need not be same. It will be different sometimes. So DM will be D1 plus D2. Actually, this is a mean. Okay, D1 plus D2. Actually, this is D1 plus D2 by 2 only. Okay, D1 by D2 by 2. And you can consider this average mean value of D, and you can put this value of DM in this formula. Okay, and finally you will get the AM. So that is the average area AM. And coming to mean sectional formula tells that hey, we need to, in mean section formula, we need to calculate the area of the two sections separately. Okay, so suppose this is area 1, okay, and this is area 2. Okay, so what will be the area of A1? A1's area will be, as mentioned in the previous slide, the area will be BD plus SD square, right? So BD1 plus SD1 square. Okay, coming to A2, the area will be BD2 plus SD2 square, and the average area or mean area will be, see, AM is equal to A1 plus A2 by 2, and using this area we'll get the total volume. You need to understand that what is the reason for calculating this AM in all the formulas. We need to have the volume. Volume is equal to area multiplied by length. Okay, so if we know the area, multiplying it with the length, we'll get the value of volume. That will be the quantity of soil required. So coming to the prismoidal formula, the formula is like this: Q is equal to L by 6 A1 plus A2 plus 4 AM. Okay, so if there is a series of cross-sectional quantity that can be found out by trapezoidal and prismoidal formula, you know, if there are only two sections in this picture, you can see we are considering only two sections, right? One is A1 and second is A2, the front face and the back face. Suppose there are many sections in between. For example, we have a section here, we have a section like this here. So if there are n number of sections on the way, for increasing the accuracy, we can have two more formulas, that is trapezoidal formula and that is prismoidal formula. Okay, so as per trapezoidal formula, V is equal to D into A1 plus AN, where A1 is the area of the first section, AN is the area of the last section, A2, and we'll have to add all the other areas. Okay, so A1 plus AN by 2 plus A2 plus A3 plus up to AN minus 1. AN minus 1 is the second last section. Okay, area of the second last section. Uh, Prismoidal formula shows that V is equal to D by 3 into A1 plus AN plus 2 into sigma odd. That means we will have to take the sum of all the area of odd sections plus 4 times the area of even sections. Okay, from these two formula we will get the value of volume that can be used, that can be considered as a quantity of soil that has either to be filled or cut. So this is the tabular column that will be used for calculating the road estimation. The first, as I think you remember the table that we had used at the time of calculating building estimations. Okay, so here the table is slightly different, and it is like this. The first column is station or chaining, second is depth or height, third is mean depth. I'll explain the terms later when we do the problem. We will see all these terms in detail. Fourth column is area of the central portion, and the second is area of the side. Area of the central portion is B into D. Okay, this is basically that explained based on that trapezium shape. You remember A is equal to BD plus SD square. So that central portion is BD and the area of sides is equal to SD square. The total sectional area will be BD plus SD square, and the length between stations need to be considered, and finally from the area, from this column we will get the area, right? And from the length we will get finally the quantity. Quantity will be basically volume. Volume is equal to area into length. Okay, so it goes like this, and this is the first problem. Calculate the quantity of earthwork for 200-meter length for a portion of road in a uniform ground. The height of the banks at two ends being 1 meter and 1.6 meter. The formation width 10 meter, side slope 2:1. Assume that there is no transfer slope. Okay, so please analyze the data shown in this question. First data is 200-meter length. Okay. Second, the height of the banks at two ends being 1 meter and 1.6 meter. Formation width is 10 meter, side slope 2:1. Actually, you need to understand the question well. So, in the previous slides, I had shown you a picture similar to this, right? I hope you remember. Right, so in this picture or in this question, this will be see this, the top surface will be uh, formation width 10 meter, so this will be 10 meter, sorry, 10 meter, then the two ends being 1 meter. The height of the banks at the two end, one end is this side and the second end is on the back side. So if it goes like this height will be, this height will be 1 meter, and this height will be 1.6. Okay, 1.6. So it is like this. This is the situation here, and also 2:1 is the side slope. So we know area is equal to, what is the formula for area? A is equal to BD plus SD square. I think we already have the value here, all the necessary value here. So we will see how it is calculated. So formation width, B is equal to 10 meter. Already told you. D1 is equal to 1 meter. D2 is equal to 1.6. Side slope is equal to 2:1. So the value of S will be 2. Usually the side slope will be mentioned like 2:1, and where It is represented in the form of s is to 1, and in this case the value of s will be 2. Okay, so we are using the first formula, mid-section area method. Mid-sectional area method shows that tells that AM is equal to BDM plus SDM square, where DM is the average of two uh, depths at the first and the last depth. So dm is equal to d1 plus d2 by 2. So 1 plus 1.6 by 2, that is 1.3 meter. We got the value of dm. So just put this value in the formula. Am is equal to bdm plus sdm square. So you will get value of b is already is written here at the top. So am is equal to 10 into 1.3 plus 2 into 1.3 the whole square. bdm plus sdm square. This formula is used, and from that we get the value of am to be 16.38 meters square. The quantity, as I told before, quantity is mentioned in volume. Volume is equal to area into length. Okay, and will be mentioned in the unit of meter. Volume will be meter. Sorry, meter cube. Okay, so quantity will be L is equal to, sorry, quantity is equal to L into AM, or we already have the value of L to be 200. It's shown 200 meter length. Okay, the length will be, that means this length will be 200. Okay, 200. So that is quantity. We get the quantity to be 3,276 meter cube. By mean sectional, we are using the same values and considering the mean sectional area method. And as per mean sectional area method, we have AM is equal to A1 plus A2 by 2. A1's value is BD1 plus SD1 square, and A2 is equal to BD2 plus SD2 square. So we are calculating A1 and A2. We already have all the value. D1 value will be 1 meter. D1 as given in the question, 1 meter. D2 is equal to 1.6 meter. Okay, so we have two values here. Am is equal to substituting the values of A1 and A2 into the formula shown at the top, and we will get the value of Am to be 16.56. And it's in the same manner that we, similar to the method we did before, if we want a quantity, that is volume is equal to area into length. This is the area and this is the length. So we'll get the value to be 3,312. We need to check. We need to check whether the values obtained from midsection and mean section are same or not. It need not be same, it will be different. Okay, in this case you can see there are some difference in the values obtained from the two formulas. Okay, so coming to the prismoidal formula, since there are only two sections, okay, there are only two sections given in the question. One is A1 and the second is A2. We can use this simple prismoidal formula. Q is equal to L by 6 into A1 plus A2 plus 4am, where L is equal to 200. A1, it's already, these values are already obtained in the previous steps. So you just substitute the values and you will get the final quantity. The advantage of this step is that we will get the quantity value of the volume directly from the formula. Before, in the other two methods, we wanted to calculate the area. From that value we needed to calculate the quantity. But here we are obtaining the value of volume directly. Okay, so next, before going to the next problem, let me show you a formula which will be useful for the upcoming problem. So this is about the area of side slopes. Suppose side slope here means in the last problem I showed you trapezium section. So there, one second. So there some side slopes were given, right? Suppose if case of similar section, this will be the side portion, and if somebody want to calculate quantity of materials used in these side slopes, we can use this formula. To calculate the quantity, we need to first we need to find the area and then multiply it with thickness. Okay, so suppose there is a thickness of materials used here. So this area multiplied by this thickness will give you the quantity of materials. Sometimes the side slope will be filled with some tiles or similar material blocks, etc. So there we need to, suppose if we need to calculate the quantity, we can use the formula. Quantity is equal to area of sides into thickness. This area can be calculated by the formula. Okay, 2d root s square plus 1 into L, where s is the side slopes. Most probably s will be, suppose normal denotation is like this, and in question sometimes it will be given 2:1, then the value of s will be 2. Okay. Okay, so we'll go to a problem. In this problem, we have been asked to calculate the area of side slope of a portion of a bank for a length of 200 meter. You have to underline the value 200 meter length. Height of the banks are two ends being 2.5 and 3.5 meter. That means D1 and D2 is 2.5 and 3.5 meter. And side slope is 2:1. That means this value will be S. Okay, so and also as a second part of the question, we have been asked to calculate the cost of pitching if the side slopes are to be provided with 15 centimeter stone pitching at the rate of rupees 150 per meter cube. Okay, so we have been asked to calculate the cost of pitch. Okay, let's see. In the question, it's already given some values. L length is 200 meter, D1 and D2 is 2.5 meter and 3.5 respectively, and the value of S is 2. Actually, the ratio was given like 2:1. So the value of S will be 2. Okay. So the area formula for area is equal to 2d root s square plus 1 into L. All the values are already given in the question. So here we need to, here the d is this dm, right? Okay, so we need to calculate dm is equal to plus d1 plus d2. This is d1 and this is d2. So d1 plus d2 by 2 is equal to 3 meter. That is the value of dm, and you need to substitute this 3 in this formula. Okay, and you will get the value of area of side slope to be 2683. So coming to volume, volume is equal to area into thickness. So we have the area is obtained from this step. Thickness is already given in the question, and see the question is mentioned 15 centimeter stone. So the thickness is 0.15 meter. Always remember that we need to use one unit for the entire problem, and you have to convert. So if given in another unit, you need to convert it into our unit. Suppose in the question it is given like 15 centimeter, and we are calculating everything in meter. We need to convert the centimeter to meter. So that's why this 15 centimeter turned out to be 0.15 meter. Okay, so this is the volume. We got the value of volume as 402.492 meter cube. Okay, and as a second, this was first part of the question, and in the second part, we have been asked to calculate the cost at the rate of 150 per meter cube. Okay, so we have the quantity here multiplied by rate, it will give you the amount. So this is a very simple problem. You need to know just the formula, area of side slope. Okay, so now it's time to go to the third problem. The third problem is related to normally this type of questions will be asked for the university exams. So I suggest you to take care of this type of problem, and you need to be very you need to go through different problems. Okay, so that uh, I mean, you will be able to understand the concepts very thoroughly. So this is in the question, uh, we we are given a lot of values. I'll tell you what are all those values. Okay, the reduced level of ground along the center line of a proposed road from chain age 10 to chain age 20 are given below. The formation level at 10th chain age is 107, and the road is in downward gradient of 1 in 150 up to chain age 14, and then the gradient changes to 1 in 100. The formation width of road is 10 meter, and the side slope is 2 is to 1. Okay, the length of the chain is equal to 30 meter. Draw the longitudinal section of the road and a typical cross section, and prepare an estimate of earthwork at rupees 275 per meter cube. You need to understand few things before doing the problem. In this so far in this topic, we have learned, based on most of the cases, we consider only two sections, right? One section at the one front section. I'll try to draw. Okay, in this problem, you remember, right? We are considering this is area 1. Okay, this is area 1, and then the back side there will be area 2. But in this problem, okay, in this problem we are given different chainage data based on different chainage. Here you need to understand that there is a term called formation level, and there is another term, ground level. Somewhere in the question it's mentioned like ground level. So what is the difference between this formation level and ground level? You need to understand that. Formation level means the level of the road. Okay, sometimes you just think in this way. Um, there will be a ground level under normal, I mean, before the construction of the road, there will be a ground level, and sometimes we need to add some soil to the ground to increase the level. Okay, so that the road will be there in a raised level compared to the normal ground level. So that formation level means the level, top level of the road. In this case, suppose this is the formation. You can see the hatched portion is the formation level. Okay, so in the question, we are given different chainages and the reduced level of the ground. This is the reduced level of ground. Okay, so 10 at the 10th chainage. Okay, so at the time of surveying, we usually chain survey. We usually do the chainage. We usually mark the chainage. So 10th chainage means the distance will be 10 into, from, if we are starting from 0, it will be nearly 300 meter, because the length of the chain is 30 meter. One length is 30 meters, so the 10th chainage will be 10 into 30. Okay, so after 300 we are considering that section from 10th chainage to 20th chainage. അതായത് 10ാമത്തെ chainage മുതൽ 20ാമത്തെ chainage വരെ നമ്മൾ കൺസിഡർ ചെയ്യാണ് ഇവിടെ. And also the reduced level of ground corresponding to each chainage is given. For example, the ground level at 10th chainage is 105. Okay, and the 11th chainage is 105.6. This is the ground level. Okay, before construction of road, the ground level is as per the data given in the table. Okay, so actually we have to calculate the estimate of earthwork at rupees 275. We need to calculate the earthwork. So for that, I hope you understood what is all this chainage means, reduced level of ground, and also in the question it's given the formation level at 10th chainage is 107. That means at the 10th chainage, okay, this 10th chainage, the reduced level of ground is 105 and the formation level is 107. Actually, what does that imply? I mean, what does that mean? The ground level is at 105 meter and the formation level is 107. That means we have to add more soil to the ground to increase the level of road to reach that 107 mark. അതായത് ഗ്രൗണ്ട് ലെവൽ 105 കിടക്കുകയാണ്. ഫോർമേഷൻ ലെവൽ എന്ന് പറയുന്നത് 107 ഫോർമേഷൻ, അതായത് റോഡിന്റെ ടോപ്പ് സർഫസ് നമ്മൾ ഉണ്ടാക്കി എടുക്കുമ്പോൾ റോഡിന്റെ ടോപ്പ് സർഫസ് 107 വരേണ്ടത്. ദാറ്റ് മീൻസ് 105 നിന്നും we have to raise the level to 107. Okay, that can be done only by adding more soil. അതായത് 105 ലെവലിൽ കിടക്കുന്ന ഗ്രൗണ്ടിലോട്ട് മണ്ണ് ഇട്ടിട്ട് we have to reach a level of 107. Okay, so അത് നമുക്ക് തന്നിട്ടുണ്ട്. 10th chainage is 107 and the road is in downward gradient. ഇവർ പറഞ്ഞിരിക്കുകയാണ് 10th chainage, suppose if we are drawing a line like this, okay, 10th chainage, 11th chainage, 12th chainage, അങ്ങനെ chainages മുമ്പോട്ട് പോവാണ്. ഓക്കെ, ഒരുപാട് പോവാണ്. 10th chainageലെ ഗ്രൗണ്ട് ലെവൽ ഇവിടെയാണെന്ന് കരുതുക. ഓക്കെ, ഒരു 105 മീറ്റർ മുകളിലാണെന്ന് കരുതുക. അതിനുശേഷം 11th chainage വന്നപ്പോൾ 11th chainage അപ്പോൾ കുറച്ചുകൂടെ മുകളിലായി, ബിക്കോസ് അതിന്റെ ലെവൽ എന്ന് പറയുന്നത് എവിടെയാണ്? 105.6 ആണ്. Coming to the formation level, the formation level എന്ന് പറയുന്നത് 107 ആണ്. ഈ 10th chainageലെ formation level is 107. Okay, so 107 ആണെന്ന് പറയുന്നു. At the same time, it is mentioned in the question that the road is in downward gradient. റോഡിന്റെ പോക്ക് ഡൗൺവേർഡ് ഗ്രേഡിയന്റ്, ഇങ്ങനെ താഴേക്കാണ്. അതിന്റെ ലെവൽ എത്രയാണെന്നാ പറയുന്നത്? at a rate of 1 in 150 up to chainage 14 വരെ എന്താണ് ഒരു particular 1 in 150 എന്ന റേറ്റിൽ it's in decreasing and after that, okay, അതിനുശേഷം കുറച്ചുകൂടെ സ്റ്റീപ്പർ ആയിട്ടുള്ള സ്ലോപ്പില് 1 in 100 പോവാണ്. 1 in 100 after chainage 14 it will go at a rate of 1 in 100. Okay, so we need to calculate the values corresponding to, we are already given the reduced level of ground at 10, 11, 12 up to 20. We need to calculate what is the value of formation level at all these chainages. Okay, we have I hope you understood what is the meaning of the question and we will go. Okay, up to chainage 14, you please focus on the steps. Up to chainage 14, the downward gradient up to chainage 14 is 1 in 150. The one chainage is 30 meter. Okay, that means 150 horizontal. I mean, this ratio 1 in 150 means that for 150 horizontal, the vertical difference will be 1 vertical. That means if we are considering 150 meter horizontal distance, the height difference will be 1 vertical. That is the rate of elevation change. For example, see the difference if we are considering the slope. Okay, this horizontal distance will be, if suppose 150, okay, the horizontal distance is 150, this vertical distance will be 1 meter. So that's the meaning of this term 1 in 150. That means for every 150 meter, for example, for every 150 meter, there will be 1 meter uh, difference in the vertical direction. That is applicable in all the units. For example, if we consider 150 centimeter or 150, in all things it will be same. So 150 units horizontal, there will be one vertical difference. Okay, so 30 horizontal. I mean, for one chain edge is 30 meter. That means for 30 horizontal, the difference will be 0.2, right? For 150 horizontal, as per the question, it was one vertical. So 30 horizontal, the value will be just 0.2. So after chain age 14, the downward gradient is 1 in 100. That means 30 horizontal means that for every chain age, the level difference will be 0.3. Okay, here what we are doing is we are calculating after every chain age what will be the level difference. Okay, that is the calculation done here. So this is for the first table. So in chain age, these two values are already given in the question. Okay, ഇത് already questionൽ തന്നിട്ടുണ്ട് chain age value and reduced level of ground. Reduced level of formation we need to calculate. ഇതെങ്ങനെയാണ് കണ്ടുപിടിച്ചത്? ശ്രദ്ധിക്കുക. This value is already given in the question. Okay. And ഈ 106.8 എങ്ങനെയാണ് കിട്ടിയത്? Remarks. The remarks column is shown. ഇതിന് മുമ്പിലത്തെ സ്ലൈഡിൽ പറഞ്ഞിരുന്ന എന്താണ്? ചെയിൻ ഏജ് 14 വരെ എന്താണ് റേറ്റ് കുറയുന്ന എന്തായാലും ക്വസ്റ്റ്യനിൽ തന്നിട്ടുണ്ട് എന്ത് ഡൗൺവേർഡ് ഗ്രേഡിയന്റ് ആണെന്ന് ക്വസ്റ്റ്യനിൽ തന്നിട്ടുണ്ട്. സോ താഴേക്ക് പോവാണ്. 107 106.8 ആയി, 106.6 ആയി, 106.7 ആൻഡ് ഫൈനലി 106.2. അവിടെ വരെ ചെയിൻ ഏജ് 14 വരെ 0.2 ഡിഫറൻസ് വെച്ച് ഫോർമേഷൻ ലെവൽ കുറഞ്ഞുകൊണ്ടിരിക്കുകയാണ്. 14 ശേഷം the rate of decrease will be 0.3. okay, so 102 ൽ നിന്ന് 0.3 കുറഞ്ഞപ്പോൾ 105.9 105.6 like that it will go on reducing. So what is the height or depth difference? Okay, so you'll have to decrease it. I mean find the difference. Okay, so the height or depth, we sometimes in some other problem we need to consider whether it is for height we need to consider positive. For example, it's positive and coming after particular stage the value will decrease, right? If it is decreasing, we need to give the negative value. In this case we are reducing. In all the cases the values are positive, so it won't be a bigger issue. So we are just reducing 107 and 105, you get 2, and subtracting 105.6 from 106.8, you will get 1.2. In that manner we are finding the difference between reduced level of formation and reduced level of ground. So we got height or depth. Okay, so this is the next table. So this table, this column we already have 1, 10, 11, 12 up to 20. This height or depth, this value was obtained from the previous table. Okay, this table, this value, okay, this value is entirely copied to this column. Okay, and the third column, mean depth. So we need to calculate what is the mean depth between 10th and 11th chain age. So what is the mean? Mean means average, and we need to take the, for example, we ശ്രദ്ധിക്കേണ്ട കാര്യം എന്താണെന്ന് ചോദിച്ചാൽ എപ്പോഴും ഇത് നിങ്ങൾ ഫസ്റ്റ് ലെവലിൽ എഴുതരുത്. രണ്ടാമത്തെ 11th ആ ഒരു ലെവലിൽ എഴുതാവുള്ളൂ. 1.6 എങ്ങനെയാണ് കിട്ടിയത്? This value is the average of 2 and 1.2. We are taking the average of the two values and writing it down. In this manner we fill all the values. How do we got this value? 1.18. This is the average of 1.2 and 1.16. So 1.18 is the average. 0.83 is the average of 1.16 and 0.5. So in this manner we fill all the values here. That is the mean depth. So what is the area of the central portion? Area formula will be, I hope you remember the formula BD plus SD square. So the central portion is BD. Okay. So we just calculate, this is the depth value. D value is obtained from here, and the value of B is 10. It's given in the question. It's given in the question that mm, the width of the road is 10 meter. Formation width is 10 meter. So B is 10, 10. Okay, 10 into, this is 10 into 1.6. Okay, 10 into 1.6. So you got 16. In this manner, multiply all the values given here and multiply by 10. You will get this area of the central portion. And coming to area of sides, we have the formula SD square. Okay, SD square. D is already, we will get the value from this column, and S, value of S is given in the question. Okay, value of S is 2. It's already given in the question. So it will be BD plus SD square, and we have to add both BD and these two columns. This plus this will give 21.12. Similar manner, you have to complete all the values here. So we got the area, right? We need to have the volume. Final, our our requirement is, we need to have quantity. Quantity is expressed in volume. So for getting the volume, we have to multiply area with length. In this, the length is individual chainage. Between 10th and 11th, the distance will be 30 meter, because the length of one chainage is 30 meter. So the length will be 30, so you have to multiply it with 21.12, and this is the area, right? This is the area and this is the length. So area multiplied by length will give the volume. Okay, so 21.12 multiplied by 30 will give you this value. In this manner, you have to complete all the entries. Then taking the sum will give you the total quantity. You have to note that there is a term banking and there is a cutting here. In this case, in this problem, in all the chainages, in all the conditions, banking is only applicable here. There is no chance for cutting here. You know, banking is other term used for filling. Okay, what is filling? എവിടെയെങ്കിലും ഫോർമേഷൻ ലെവല് ഗ്രൗണ്ട് ലെവലിനേക്കാൾ മുകളിലാണെങ്കിൽ, ഓക്കെ, നമുക്ക് ഉണ്ടാക്കിയെടുക്കേണ്ട റോഡിന്റെ ലെവൽ നോർമലി ഉള്ള ഗ്രൗണ്ടിനേക്കാൾ മുകളിലാണെങ്കിൽ നമുക്ക് മണ്ണ് എക്സ്ട്രാ നമ്മൾ ഇടേണ്ടി വരും, അല്ലെ? സോ അതിനെയാണ് ബാങ്കിങ് അല്ലെങ്കിൽ ഫില്ലിംഗ് എന്ന് പറയാം. കട്ടിംഗ് എന്ന് പറഞ്ഞാൽ നമുക്ക് ഉണ്ടാക്കേണ്ട റോഡ് നോർമൽ ഗ്രൗണ്ട് ലെവലിനും താഴെയാണെങ്കിൽ നമുക്ക് ഇപ്പം നിൽക്കുന്ന ഗ്രൗണ്ട് ലെവലിൽ നിന്ന് അത് കട്ട് ചെയ്ത് മാറ്റണം. ആ മണ്ണ് മാറ്റെങ്കിൽ മാത്രമേ താഴോട്ട് എത്തുള്ളൂ. സോ അതിനെയാണ് കട്ടിംഗ് എന്ന് പറയുന്നത്. ഓക്കെ, സോ ഇൻ ദിസ് കേസ് ദ എൻറ്റയർ entire problem, cutting is not applicable. So everywhere it will be banking. So and this column will be empty. This column will be empty, and all the values we have to fill it in the banking column. So you can take the sum and get the final value. Suppose if the rate is 275 per meter cube, we have the quantity as 3513.6. You have to multiply by rate, it will give you the cost, adding 5% contingencies, and you get the grand total. Okay, grand total is shown here. So this is the usual way of calculating road estimation problem. Okay.